All right, mathletes, here's 10.8 linear programming. First, we got to talk about some vocabulary. First one is constraints. It's a system of linear inequalities whose graph is called the feasible region. A lot of the times those constraints are based upon supply and demand and availability of resources and costs. Corner point principle. The corner point principle is going to help simplify things because any maximum or minimum value of a linear combination will occur at a corner point of the feasible region. So we'll be testing corner points. The objective function is what we'll be testing those corner points for. And an objective function is a function that is to be maximized or minimized. Many times it's a function of profit if we're trying to maximize profit, or maybe it's a function on cost and we're trying to minimize our costs for production of something. So first is just the nuts and bolts here. If we're asked and we're given to maximize this function, notice that we always have a third variable with this is our objective function here. And we're going to have it equal to some third variable. It's going to have two inputs. So functional notation, this might look like f of x comma y, where you input an x and a y and you get some value out. For this, we're just calling z. Okay, and then we have our restraints. So first restraint here is that we have x is greater than 0. So what we want to do is go ahead and graph that function. And we're going to graph that. I'm going to use blue. And I'm going to graph that function here. So all values where x is greater than 0. Now I'm going to graph functions that this one that is y is greater than 0. So I'll do it in a slightly different color. And y is going to be greater than 0 there. Okay, so we're shaded above and to the right of those lines. And then x plus y is greater than 2. Let's go ahead and graph that one here. X plus y, that's going to have an x and y intercept of 2. And so I can graph that here and here. Only really concerned with the feasible region here that we're dealing with. Since the x and y's have to be positive, we know that it's got to be just a quadrant 1 type scenario. Okay. The next one is x plus y is less than 8. So x plus y, that's going to have an x and y intercept of 8. So I'll go ahead and graph that one. And that's going to be here from 8 to 8. And then 2x plus y is less than 10. So that's an x-intercept of 5 when y is 0, and a y-intercept of 10. So let's graph this line in dark red, and we're going to do so when x is 0, y can be 10, and when y is 0, x is going to be 5. Okay, so that's less than. So then if we shade all these, what we're going to get is this feasible region. In this area. And things have to be greater here. And so that shaded region is our feasible region for this function. So what's nice here, now I want to maximize this function, so I'm going to look at my corner points. So my first corner point is up here, and that is when it's 0, 8. And then my next point is at the intersection of these two lines. Well, sometimes to find the intersection, it might not be as clear on graph, so I know it's from this function here and this function here. So if I want to, I can just solve and find when those two are equal to each other. So I'm going to set it up as x plus y is equal to 8, and 2x plus y is equal to 10. So this will set up nicely for elimination. So I can do 2x minus x is x, y minus y is 0, and 10 minus 8 is 2. So x equals 2. And then I can see that when I plug in 2 into my equation, I get a y value of 6. And sure, that's verified here on the graph as well. My next corner point is right here. So I'm going to have a solution of 5, 0. And I have this other corner point here, which is 2, 0. And then this corner point here, which is 0, 2. So those are all the values I have to test when through my functions f of x of y, or to maximize z. So I'm going to put those all in that function. So if I do f of 0, 8, well, that's going to be 8 times 3, so that's 24. F of 2, 6, well, that's going to be equal to 2 times 5 is 10, plus 18, so that's 28. So f of 5, 0 is going to be equal to 25. And then f of 2, 0 is going to be equal to 10. And f of 0, 2 is going to be equal to 6. So since I am trying to maximize this, I notice my maximum value here of 28. So 2, 6 is going to be what's going to maximize this linear programming problem. All right, so let's look at an example of a word problem here. So we have a crafter of vegan candles here that want to sell them in a shop. So the crafter is making 2 sizes of vegan candles. The crafter's cost is $3 for the small candles and $5 for the large. The shop owner requires that at least 15 small and 10 large candles be sold in the first month in order to continue the line. It will take up to a total of 50 candles in the shop and sell them. The crafter sells the small candles for $7 and the large for $11 in the store. So we want to try and figure out, as a crafter, what should we do to maximize our profit? So first thing we're going to do is define variables and write the constraints. X and Y are going to be our first choice because that'll lend itself to graphing fairly well. So X, let's go ahead and say is our small candles, and Y is our large candles. And let's write the constraints. So what are we limited on? Well, first we know that we have to have at least 15 small ones. So since X is small, we got to have X greater than or equal to 15. The wording here, at least, I know it's inclusive at 15 and 10 large candles. So again, Y has to be greater than 10. Okay, but I'm limited with the amount of candles that the owner will take. So my X plus Y has to be less than or equal to 50. So I have those constraints there. And with these, I have some other constraints that are kind of a bit common sense. And we just want to make sure when we graph this, we can't make negative candles. So that's going to restrict our to the first quadrant. So X has to be greater than or equal to 0, and Y has to be greater than or equal to 0. Okay. So next step in this process is we want to graph the feasible regions that represent all possible combinations. Well, my first one, so I'm going to graph my first one here. X has to be greater than 15. So X has to be greater than 15. So I have 10 here and 15's here. So I'm going to have that. And Y has to be greater than 10. So I'm going to have that. And then my X plus Y is less than 50. So X plus Y is less than 50. So I both get an X and Y intercept here at 50. And I suppose I didn't need X greater than 0, Y greater than 0, because I had a minimum amount that I could make for the shop. So my feasible region now is going to be here. Okay, so that's the possibilities for me to sell candles, or this crafter to sell candles in the shop. So if I want to test these, I'm going to have these 3 points of interest to me. I'm going to have this value, Well, that's when X is 15, and that gives me a Y value of 35. My next corner point here is a Y value of 10 and an X value of 40. And then I have this corner point here, which is going to be an X value of 15 and a Y value of 10. So next piece is I want to write my profit function, my objective function that I want to maximize here. So my profit is always going to be equal to what things are sold for minus the cost. Well, what things are sold for is this right here. So we get $7 for our small one plus $11 for our large one. Then we have to subtract away our costs. So we have to minus, well, the cost of the small candles is 3x minus the cost of the large candles, which is 5y. So I can see for every small candle I sell, my profit when I collect my like terms is $4, and I get a profit of $6 for the large candles. So this is my objective function, f of x of y, or we could say that's z if we wanted to. Okay, so I have my corner points down here. So if I want to maximize my profit, I want to make sure I test these values. So f of 1535 is going to be equal to, get my calculator out to do this, so 4 times 15 plus 6 times 35, and that's going to be equal to $270. So my next one is f of 40 and 10. So this is going to be 4 times 10 plus 6. Sorry, that's 4 times 40. And 6 times 10. And I get that's 220. And then my last one is 4 times 15 plus 6 times 10. And I get 120 at the corner point 15, 10. So I am trying to maximize my profit. What I want to do is go along these guidelines. I want to make 15 small candles and have 35 large candles. Okay, make sure you highlight any questions you have on notes tonight and bring into class tomorrow.